Okay, so we switch the x and the y. We switch the x and the y, and then we solve for y. So you take the square root of both sides. And when you take the square root of both sides, you end up having to do plus or minus, right? So we recognize that the inverse function is going to be plus or minus the square root of x. Now what I want to do is I want to just take the original function, y equals x squared, and I want to review what we already know about it. Now we did this weeks and weeks ago. But what were the three most important points I told you to remember about y equals x squared? 0, not correct. 0, 0, right? If you plug in a 0, you get out a 0. Plug in a 1, you get out a 1. Plug in a 2, you get out a 4. And then you could keep going, couldn't you? Okay, and you know you could keep going. But those were the important points I told you to kind of get started with. Now, if this is the inverse of this, well, wait a second. First, we should graph this. Let's graph that first. All right, so 0, 0, 1, 1, 2, 1, 2, 3, 4. And then we used our line of symmetry, and we ended up with a nice, pretty parabola, right? You remember we did this? It's been a month or so. Okay? So hopefully your parabola is prettier than that. Mine's pretty ugly. All right. Let's talk about the inverse as far as how can we draw an inverse based off of the points. How can I take these points and find the inverses? Switch them, right? So 0, 0 switches to same thing. 1, 1 switches to 1, 1, same thing. But what does 2, 4 switch to? 4, 2. And we did this yesterday, right? So my inverse function should look like that. So now I'm going to take that information and go graph it. 0, 0 ends up being the same. 1, 1 ends up being the same. But then 4, 2 ends up being here. And I can graph that. Now, this was not... how do I get the rest of it to make it look like an inverse? Okay, I could use my symmetry, right? So I could put a point here and a point here, and I could make that symmetrical, the rest of it. But what's the problem with this? We talked about it yesterday. What is the problem with this? It's not a function, is it? It fails the vertical line test. If I draw a vertical line anywhere, right there, it fails the vertical line test. Oops, wrong button. It fails the vertical line test here and here. So it's actually not a function, is it? So with that being said, even though this is the green function is the inverse of the black function, in other words, plus or minus square root x is the inverse of y equals x squared, what we're going to do is we're only going to focus on the function part of it. So what we're going to do is we're just going to forget about the negative part, and we're only going to focus on this part right here, okay? The positive part, and that's where we're going next. Okay, just exploring this a little bit, notice that we know where the points that we wrote down before, notice they're on the graph, right? 0, 0 is on the graph, 1, 1 is on the graph, and so is 4, 2. You know, 0, 0 was labeled, 1, 1 is probably about there, 4, 2 is probably about there. So they are on the graph. For square root functions, these are going to be the 3 points I need you to know. They're the parent points. They're the most important points. Okay? But now let's talk about this for a second. Let's talk about the domain of this. The domain of this one is different from the domain of anything we've done before. Okay? Remember, domain talks about all possible x values. So I want you to look at the x values. I can choose x equals 0. I can choose x equals 1. I can choose x equals 2 and 3 and 4. And I can keep going forever, right? But what numbers can't I choose? So as you can tell, we can choose all of these red x's, 5, 6, 7, 8, 9, 10. What numbers can I not choose? Negative. They're not on my graph, are they? So if you look right here, these are not defined. These are not defined on my graph. And why are they not defined? Well, think about this. Plug in one of these numbers that's not defined. Plug one of these numbers into this. Pick one of these numbers, any of them. Negative 1, great choice. If I choose negative 1, what is the square root of negative 1? Thank you, it is I. But it's imaginary, right? It doesn't exist. It's not real. Square root of negative 2, square root of negative 3, square root of negative 4. None of these are defined. So we have to leave them blank. They're undefined. So as you can tell, only the x's that are bigger than or equal to 0 represent the domain. Now talk about the range for a minute. Okay, the range are after you start plugging in x's, what kind of y's do you get? Well, as you can tell, I can get a y equals 0, I can get a y equals 1, eventually I'll get a y equals 2, and a y equals 3. So those will keep going up, won't they? So what kind of y's will I get out? Well, not all real numbers, because did I ever get any numbers down here? I never got any numbers below the x-axis, did I? So all of my y's are also greater than 0, and that's what this is talking about. Okay? We're not going to mess with the intercepts much, but I do want to talk about the end behavior. I'm going to clear all this off, but I'm going to talk about the end behavior. Okay? Just glancing at this graph right here, yesterday we were talking about the end behavior. We'll start with the positive x's because it makes the most sense. As my x's keep going forever this way, so as x approaches infinity, what are my y's doing? They're going up, aren't they? They are going up. Yes, they are. So my y's also approach infinity. Now, on a square root function, they don't go up very fast, but they do go up. This will never turn and come back down. Okay? So they do go up. But now let's talk about the other time. Last week, we talked about x approaching negative infinity, right? So that's going this way. Well, can I even choose these numbers? So this doesn't even make sense. So we won't talk about x approaching negative infinity. Instead, we'll talk about x approaching this end right here. So what's my lowest x? 0. So as x approaches 0, what does y approach? It also approaches 0. It was up here, and it starts working its way down, 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 and it approaches 0. So this is going to be the end behavior. It has to do with where this point is, where the whole thing starts. Let's take a minute and let's graph one. As we're going to graph these things, I do want you to remember way back when, at the beginning, the first week of school, remember how we could move functions to the left and to the right? How could we move functions to the... how do we move functions up and down? You add some sort of number on the outside, right? Doesn't that move functions up or down? All right. What about moving functions left and right? It wasn't a divide. It was adding on the inside. On the inside is what moved them left and right. Well, that's how we're going to graph these. Because if you'll notice right here, square root of x is my parent function. That's my parent function. So what's happening to this parent function? We're taking this parent function and moving it up 2. So that's how we're going to graph these. Okay? So my original function, remember, I told you these points to remember. 0, 0, 1, 1, and 4, 2. Now 2, 4 was the quadratic, so this is the opposite. So I want to graph my original function. I did those in orange. I should have done those in black. So my original function is 0, 0, 1, 1, and 4, 2. Okay? And that is my original function, parent function. But this specific function is going to be different. How is this function different? It's going to be the same function but moved up 2. So this one we're going to move up 2. I'll do that in blue. So instead of starting at 0, 0, I'm going to move it up 2. It's going to be 0, 2. Instead of being at 1, 1, it's going to be at 1, 3. Yeah. And instead of being at 4, 2, it's going to be at 4, 4. And there's my function. And my blue function is y equals square root x plus 2. Notice the plus 2's on the outside, right? Okay, so we're just using our transformations of functions like we did at first week of school. Talk to me about domain and range. The domain of this function, my blue function, are my x's such that, what's the lowest x value I could choose for this? Alright, it's right here, it's 0. Okay, so my x's have to be greater than or equal to 0. What about my range? What kind of numbers do I get out when I plug in those zeros and up? Okay, I get all of these numbers here that are 2 or bigger. And they will keep getting bigger. So all my numbers greater than or equal to 2. There's my domain. End behaviors. As x goes to infinity, as x goes to positive infinity, what are the y's doing? They're also going up, 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 right? Not very fast, but they are going up. So that's still positive infinity, positive infinity. But what about going to the left? X doesn't really go to negative infinity, does it? What's the lowest x is going to go? 0. And as x goes to 0, what does the y do? It goes to 2. It doesn't go all the way down to 0, does it? It comes along here, and the farthest the y goes is right here at 2. Talk to me about how this function is being changed. I'm taking the normal function, square root x, and I'm moving it how?
Down 3.
Okay, this means I move it down 3. And this means I move it right 2. Do you remember that? That's from the first week of school. Okay, so I'm going to go do my normal function. My normal function is this one. 0, 0, 1, 1, and then 4, 2. That's my normal function. And I'm going to move it. I'm going to move it just like you told me. I'm going to move it to the right 2 and then down 3. So my new one is going to be right 2 and down 3. Take each of these dots and move it 1, 2, 1, 2, 3. And then here, and then here. Oh, that's not right. All right, let's talk about domain and range. What is the domain of this? Looking at the graph, and then I want to look at the equation to talk about the domain and really explain why it works. What is the domain looking at the graph only? What is the lowest x value that I use?
2.
It looks like right here. Okay, so this 2 right here, that's the lowest x value. So my domain is definitely all my x's such that x is greater than or equal to 2. But now that's looking at the graph. I can actually determine the domain without looking at the graph. Okay? I just need to look up at the equation. Remember, what is the whole reason that the domain is restricted? Because I don't want the square root to ever be negative, right? So in other words, I want x minus 2 has to be greater than or equal to 0, doesn't it? Whatever's on the inside of your square root must be greater than or equal to 0. Well, look, that's just a super easy little inequality. Solve that. X is greater than or equal to 2, and is that your domain? It is. So that's one way you can find your domain without having to look at the graph. Okay, and I would expect you to be able to do it both ways. Now talk about range. Range is going to be what kind of y values do you get after you know your domain. So just looking at the graph, what kind of y's do I get?
Greater than negative
Okay, negative 3 was the lowest, right? Right here was negative 3, and it's everything above that. So my y's, such that y is greater than or equal to negative 3. Okay? By the way, if you were to go to your domain, plug this one into here, what answer do you think you'd get? Plug in your 2. Plug in your 2 that you just found from your domain. 2 minus 2 is 0. Square root of 0 is also 0. 0 minus 3 is negative 3. So see, you can actually figure these two out without ever having to graph it. Okay? In behaviors, as x goes to infinity, what's the y doing? It's still going to infinity. It doesn't go up fast, but it does go up. Oh, sorry, it's the orange one. And as x moves to the left, what's the lowest it ever gets as far as x's?
0.
No, it never makes it to 0. It only gets here to 2, right? So as x approaches 2, what happens to the y's? They approach, what's the lowest the y gets? Negative 3. So do you see the domain and the range are important to talk about with as far as these two go, right here. All right, so we recognize that the square root of x is going to be, let's see, it's going to be down, how much? 3? What does the 4 do? What does this 4 right here do? Okay, it moves it to the left, 4. And now let's talk about this 2. What's the 2 do? It means that all the y's are 2 times bigger. So do you remember before when we had this, when we said 0, 0, 1, 1, and 2, 4? Well, these are all going to change to be 2 times bigger. So it would, well, that would still be 0, but this would change to a 2, and that would change to a 8. Oh, I totally did that backwards. Yeah, I got to fix that. I'm so sorry.
What?
So thanks for pointing that out. So this would have been 4, 2. Okay? So, but these are all going to be 2 times bigger now. So that's what this 2 out front does. All right? Other than that, we can just graph a normal graph. So find your normal graph and then let's move it. Change it. See what it's supposed to look like. The normal graph, you'll get tired of it, but it looks like this. I do encourage you to always draw the original graph because it just helps you, keeps things straight. And now my new graph, I've got to move it, just like you told me, I'm going to move it down 3 to the left 4, and then all my y's will be 2 times bigger. So let me move the point first. I need to move it down 3 and left 4. So I'm going to move it down 3, 1, 2, 3, left 4, 1, 2, 3, 4. So right there will be my point. And that's 0, 0. Okay? But remember, from here on out, I'm not going to go 1, 1. I'm actually going to go 1, 2. So as I'm looking at this, I would normally go over 1 and then up 1. Now I'm going to go over 1, and all my y's are twice as big, so it's going to be up 2 to here. And I would normally go over 4 and then up 2, but now I'm going to go over 4 and up twice as much. So it ends up being here. And I might even have room on my graph to get that 1 more. What would the next pretty point be? It's not on my list. It'd be, well, backwards. It'd be 9, 3, right? So I'm going to go over 9, 6. That's exactly right. So I'm going to come over here and count over 9. 1, 2, 3, 4, 5, 8, 9. Up 1, 2, 3, 4, 5, 6. All right. And it ends up making a pretty nice looking graph. All right. So that is my y equals, all that stuff. That's y equals, actually, to, oh, I'm not even going to put that there. Because this isn't an equals problem, is it? This was an inequality. Now I can talk about that inequality. What does the inequality mean for me to do? Look at this sign right here, a less than sign. Remember, this is going to be below my function. And also, it's actually a dotted line, isn't it? So I really need to go back to my graph. I should have done a dotted line instead. So I'm going to try to make that a dotted line, because those really don't count, do they? Including this endpoint is really an open circle. And now, when I say below, what does it mean below? That means I'm going to shade it below. That's exactly right. So, because this is a less than sign, I'm going to shade everything less than my graph.
That's cool.
New tricks. Alright. Now that leads me with one more question. I asked you to do domain and range. The domain doesn't really change much. My domain are still all the x's that I've graphed. So remember, I can only choose x's as far to the left as here. So what are my x's?
Greater than -4.
Greater than -4. Now I like that you did not say equal to. Can it be equal to?
No.
No, because look at my sign. So it actually cannot equal that. So just greater than -4. So I'm glad you noticed that. Now let's talk about the range. The range is a little tricky here. Think about the range. What kind of y's did we get? Normally, these y's go up, 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 up forever, right? Are they still going to go up forever? Yeah, they are. So going up is not a problem. And what's all this shading do?
Show you where the y's can go.
It tells you, well, it tells you where the y's can go. So actually, I have all of my shading covers all the y's that go down. My graph keeps going up forever. Is there any y that I will never cover? No. My y is all real numbers. And that doesn't happen often, but it does happen when you shade them.